Okay, hi folks, this is the third video segment for the solution to homework number 11. Okay, I think some of these word problems were left out, so let's go ahead and try to do it here. Uh, Problem number 30. Number 30. Okay, so it says find the length AD. Now here we have to use a little bit of our brain. Notice that what I have here, look at this triangle BCD right there, BCD. These two sides, DC and BD, are both 12 units long. If that is the case, we are dealing with an isosceles triangle. An isosceles triangle means that this angle and that angle are the same. So this angle immediately is 25 degrees. Then we go to this other triangle here. So let me change the color of the pen. So ADC. Look at the triangle ADC. Look at this angle. The angle here added to this angle is 180 degrees. But this green angle added to 25 and 25 also gives you 180 degrees. So the angle here at the point D, which is between lines AD and DC, is 50 degrees. So the situation is as follows. We have, let me clean this. Oops, it crashed. Let me see. Let's go back here. Okay, this is the problem that we were doing. All right, so this triangle, which looks like that, there is C, and there is D, and there is A. We figured out that this angle is 50 degrees. Of course, this is 12 units, and that angle is given to us as 25 degrees. So we can use the law of the sines in order to find the missing side AD. The sine of 25, sine of this angle, sine of the angle C, 25 degrees, divided by the face, that is the edge that's facing that, namely AD, which is what we want incidentally, is equal to sine of this angle, here, which incidentally is 25 plus 50 is 75. So this angle must be 105. 105 degrees over 12. Okay. So I've used this edge and the angle facing it, and I've used that edge and the angle that's facing it, and this is what we get. So AD becomes equal to 12 sine of 25 degrees, don't forget the degrees here, over sine of 105. Now I have to go to my calculator. So let's go to the calculator here. I'm sure my mode is on degrees because the other problems that we're doing are also in degrees. So we're going to check it out. Okay, we're going to check it out. Okay, so the free version of 67 days left. All right, let's check the mode. I'm going to clear all of these things. So clear all of these. Check the mode. The angle is degrees, as you can see. So that's fine. Now let's go back there. Clear this. So we want 12 times sine of 25, close the parentheses, divided by sine of 105 degrees. 105 degrees, close it, hit enter, and you get 5.25. So if you go back to this, so this is approximately 5.25 units. Okay, so for example, these are in inches, 12 is in inches, this is going to be 5.25 inches. Otherwise, whatever the unit is. Okay, let's go to the next one, problem number 34. So I'm going to erase all this stuff. We don't need it anymore. Okay, let's see what we've got. We're doing this problem. It says a pilot is flying over a straight highway. There's the highway. Okay. He determines the angle of depression to two mileposts 5 miles apart. 5 miles apart. The angle of depressions are 32 degrees and 48 degrees. Find the distance of the plane to point A. Okay. So let's see now. If this angle is 48 degrees, this angle is also 48 degrees because these two lines are parallel. And this angle is, for example, is also 32 degrees. Okay. So what we can. Oh boy. Okay. So in this triangle that you see here, we have. Let me call this thing the point D so that you can see it. The point D. So in this triangle, we have a sine of 48 degrees over AD equal to, well, I need to know what this angle is. This angle, that's very easy because it's a complement. If you add 32 and 48, you get 80. So this must be 100. Okay. So it's equal to sine of 100 degrees divided by, these are all degrees, by the way. These are all degrees, divided by 5 miles. So AD is equal to 5 sine of 48 divided by sine of 100. Let's go put that stuff in our calculator. Okay. Yep. So we go here 5 sine 48 over sine of 100. So we put down 5 times sine of 48, close the parentheses, divided by sine of, sine of 100. And hit return. You get 3.77 miles. If it's rounded to the second digit, 3.77 miles. So this is approximately 3.77 miles. Now the other one is the elevation. The elevation is obviously, the elevation is this height, okay? Which is, now that we got AD, this is 3.77, approximately AD is 3.77. In the right triangle that you see here, we can write down sine of 30 degrees. Well, you know what? I think I made a mistake. This is supposed to be 32, okay? This is supposed to be 32, not 30. But I never used that angle anywhere. I'm going to be using it right there. Sine of 32, although I put down 30, but it's supposed to be 32, but that's okay because I never used it. Sine of 32 degrees is equal to the opposite, which is the elevation, divided by hypotenuse, which is 3.77. So elevation, which is this height, okay, elevation is equal to 3.77 times sine of 32 degrees. So let's do that. 3.77 times, by the way, sine of 30 degrees, I don't have to put it in there. We know what it, oh, 32 degrees, yeah. Sine of 30 is half, but sine of 32, I have to put it in. So sine of 32. If it was 30, I would just say the answer is half, okay? Sine of 30 degrees is 0.5. And this is going to be close to 0.5, but it's not going to be exact. 1.99, and if I round this thing to do digits, it's going to be obviously 2. 1.997, if you round it to the second digit, it's going to be 2, approximately 2. So, yeah, approximately. I'll write it like this, 1.9977. How about that? Okay, so let's go and do problem number 37. I'm going to erase some of this stuff. Okay. All right. Okay, so we have the bell tower of the cathedral in Pisa, Italy. Looks like that. It's a leaning tower. Looks like this. So let me draw it represented by this line. And this angle is very small, 5.6 degrees. That's okay. Okay. It says, oh, from the vertical. Oh my God, if this was 5.66, the tower would be on the ground. So this is 5.66. 5.6, not this one. Terrible. All right, what do we got here? A tourist stands 105 meters from its base. So a tourist stands here, and this is 105 meters. With the tower leaning directly towards her. Okay, fine. She measures the angle of the elevation to the top of the tower to be 29 degrees. So that means that the angle of elevation, now the angle of elevation is, I'm going to redraw this diagram, but that's what the angle of elevation is. This is 29 point, what is that? 29.2 degrees. We're going to have to redraw this, okay? So it's better if I drew it like this. This angle is 5.6 degrees. This is the tower, and there's the tourist standing here. The tourist standing there, and the angle of elevation is this angle. It's 29.2. Now, of course, we are assuming that this tourist is find the length of the tower to the nearest meter. So we are assuming that this tourist is actually a midget right there. So this angle is 29.2. In fact, the tourist is a midget compared to the leaning tower. So what you want to know is what is this the length of the tower? The length of the tower. So this is the length of the tower. Let me put some labels here: A, B, C, D, A, B, C. Okay. So if this is 29.2, this angle 90 minus 5.6 is going to be 45, no, not 45, 50, uh, not 50. Take 90 and subtract 5.6 from it. That's where it is. So it's going to be 84.4 degrees. Okay? 84.4 plus 5.6 is 90, and that's the way it's supposed to be. So remember, AC is 105 meters. So based on the law of the sine, so we have sine of 29.2 degrees divided by the length of the tower, the height of the tower, equal to, now I need this angle, divided by 105, which is AC. This is AC, by the way, okay? So this angle is going to be 180 minus 84.4 plus 29.2. Okay, so let me do this thing in my on my cell phone. That angle up there is going to be okay, 180 minus 84.4 minus 29.2. That angle up there is 66.4. So this angle here, 66.4. I hope I didn't make an algebra error, but you work it out. Sine of 66.4 degrees. So now we're going to find the length AB, the length of the tower. Okay, so let's do that. So AB is equal to 105 sine of 29.2 degrees divided by sine of 66.4 degrees. So let's work it out. Okay, so we go here, 105 sine of 29.2, 105 times sine of 29.2, close the parentheses, divided by sine of, I think it says 66.4, right? 66.4, and isn't that what you came up with? Yes. Okay, and then hit enter, and you're going to get 55 meters. To the nearest meter is going to be 56 meters. So this is approximately 56 meter. Now notice that the height of the tourist, even if it was 2 meters, that's a tall person. The height of the tower is about 26 times, 27 times bigger than the height of the guy. That's why it really doesn't matter. We consider this person to be right on the ground. There's having no height. That's the next thing. Okay, let's go to the next one. You know what? Let's get rid of the stuff. I still have not managed to get a hang of this erasing of these things without too much pain. Okay, let's bring it up here. All right, what have we got? Number 40. The communication tower is located at the top of a steep hill, right there. The angle of inclination of the hill is 58 degrees, so I can see this thing well. Okay, 58 degrees, fine. A guide wire is to be attached to the top of the tower to the ground. Okay, so this is the guy tower, a guy wire on the ground, 100 meters downhill from the base of the tower. So 100-meter downhill from the base of the tower. Now that's kind of a vague statement because I'm not sure. We'll find out. Base of the tower. The angle alpha in the figure is determined to be 12 degrees. Okay, so this is 12 degrees. All right. Find the length of the cable required for the guide wire. Now, I'm still not quite sure exactly what they're saying here, so let's read it again. A communication tower is located at the top of a steep hill. Okay, so there's a steep hill. You can see that, right, like this. Okay, fine. Oh, yeah. Okay, so that's what the hill is, right? 58 degrees is down here. Okay, this is angle alpha. Fine. The guide tower is to be attached to the top of the tower and to the ground. 100-meter downhill from the base of the tower. Now, my guess is that they're saying this is 100 meters, this length. This is my guess. I don't know. All right. Um, the angle alpha is 12 degrees. That's the angle alpha. And find the length of the cable required for the guide tower. Yeah. So, okay. So this is the situation. Now let's see. So we have a triangle like this. We have a triangle like that. This angle, it looks to me, this is what the problem is. This angle is 58 degrees. And if you look at this, right triangle, this one, I can find that height. I can find this height. I'm not sure. My guess is that, well, my guess is that the 100-meter is not this height that I'm showing here, this length that I'm showing here. Let me clean this. My guess is that the 100 meters is this height. This height. So we have a right triangle here. This angle is 58 degrees. This is 100 meters. So what we can do is to find that height. This is the hypotenuse. So this hypotenuse, I'll call it h. How about h? H equal to 100 meters, of course, divided by sine of 58 degrees. So we're going to get this length, okay, this length. Let's do that. 100 divided by sine of 58. 100 divided by sine of 58. And that is 117.9. So let's go ahead and put it in the diagram here. So this is 117.9. So now we have this is the guide tower. This is the cable. Guide cable. Is that what it says? Guide wire. Yeah, right. And okay, so we have a triangle like this. I'll call this thing A, B, C. We found this thing to be 117.9. We have this angle, and that angle is 12 degrees. Okay. And this is a vertical line, by the way. This is a vertical line. This angle This angle over here is 58 plus 12. 58 plus 12 is 70. See this angle? See this angle? Right there. This big angle here. 12 plus 58 is 70. So this angle is 70. That means this angle is 20 degrees. In that right triangle, we have one edge and two angles. So let's write it. If this is 20 degrees, the angle over here, let me see now, this angle is 20 plus 12 is 32 minus 180, so it's going to be 148, right? This big angle is 148. If you add these up, you should get 180. Do you get 180? 32 plus that is 180. Very good. Okay, so we have AB, we have sine of 148 divided by AB. That's what you want to find, right? The length of the cable. Okay, so this is equal to, for example, sine of 20 divided by 117.9 meters. Okay, so AB is equal to 117.9 sine of 148 divided by sine of 20. These are all degrees. Okay, so let's go ahead and put this thing in there. So 117.9 times sine of 20 divided by sine of oops, oh God, the backspace. Let's try it again. 117.9 times sine of 20 divided by sine of, oh my God. Oh yeah, I keep pressing the button on my keyboard. I have to use these things. That's fine. Let's go back here. Sine of there. Now I have to backtrack. Let me get rid of this stuff. Oh, I'm sorry. 117.9 times sine of 20 divided by sine of, clear. One more time. 117.9 times sine, where's the sine here? There's the sine of 20 divided by sine, not the keyboard sign, this sine of, I can't remember now what it was. What was it? Sine of 1, actually it was the other way around. Sine of 148 divided by sine of 20. So we have to, so this is going to be 148. 148. Close the parentheses. Divided by sine of 20. We finally, oh, not yet. We finally did it. Close the parentheses. There we are. 182.6. So this is going to be approximately 182.6. Okay. Wow. Meters. Okay, now notice that these word problems, some of them may be vague. because of the drawing or because of the statement of the problem, etc. Got to do it a few times. If not, check with somebody else, with me, with I don't know, the book, MATLAB, friends, and eventually you're going to get it. Now, how much time did I spend on this? Okay, so observers, this thing down a little bit. I may have to break this up, by the way, into another segment, but we'll find out. Observers P and Q are on the side of the hill, P and Q on the side of the hill, that is inclined at 32 degrees, so 32 degrees to the horizontal. The observer P determines the angle of the elevation of the hot air balloon 62 degrees. So let's see now. So the angle of elevation of observer P, that means, oops, if it's horizontal, this angle is 62 degrees, angle of elevation. At the same time, the observer at Q measures the angle of elevation to be 71. So this guy measures that to be 71 degrees. Okay. P and Q are 60 meters apart. Find the distance from Q to the balloon. Okay, so what do we have here? If this angle is 60, let's see. Let me clean this up. Let's go ahead, redraw this. Okay. First of all, I want to make this thing nice and you know what? I'm going to stop this thing and make the last one in another video segment because it looks like this is acting up.